principle of rotation of wind turbine energy. So in order to convert the wind energy, whatever wind energy, into useful function, so there must be a mechanism is required by which the force of wind can rotate that particular mechanism. So there are two types of principles are used to produce force by the wind. First, aerodynamic drag principle. Second, aerodynamic lift principle. Now first let us see what is aerodynamic drag principle. When any object is placed in the stream of air, it experiences a force through an air stream on the edge of the object. So there are whatever the force F is occurs on this object has two components. Now the one component, it is in direction of the air stream, is called drag component, and it is represented by capital T. Now the another component which is perpendicular to the air stream, to the direction of air stream, which is called lift component, which is represented by capital F. So the resultant of these two components is the force exerted on this object which is placed in the flow of air. Now here the drag force, it is works in the direction of air stream. Now suppose here we can say that one flat plate is placed in the air stream. So if the air stream is applied on this flat plate in perpendicular direction, that time maximum drag force D is occurs on this plate. But if the air stream is the direction of this flat plate, it is in direction of this wind air stream, that time the minimum force occurs on this plate. So initially the wind turbines are drag force type. In this type of turbine, the value of the torque exerted by this turbine is high, but its speed is very low. Now such type of characteristics of this type of principle of this rotor, so this type of principle, it is used for the lift the water for the pump. It is and second, grain of grinders we are using. So its efficiency is 50 to 30%, and the performance coefficient, it is lies between 0.15 to 0.3. Now next, aerodynamic lift principle. So the force exerted which is perpendicular to the air stream. The lift force seems to be minimal when the direction of this wind stream forms a zero angle with this flat surface of this plate. But if the plates makes a side angle with the air stream, and if the velocity of this upper side wind stream is increased, then the upper side pressure decreases and lower side, here the lower side pressure is increased. Now thus creating a pressure difference between two sides of this plate produce a lift force on the surface. So in aeroplanes, this lift force lifts the plate into the atmosphere. So now whatever the angle created between air stream and the plate is called angle of attack. It is most important. So nowadays the horizontal axis type wind turbines are used. Now in this turbine we will get medium or high torque and we are also getting higher speed in compared to aerodynamic drag principle. Now its coefficient of performance is between 0.3 to 0.4. So now this type of turbine, it is used to generate the electric power. Now next, aerofoil. So aerofoil section may be asymmetrical or asymmetrical. Here you can see the aerofoil section. Now the leading edge of this aerofoil, you can see the leading edge of aerofoil is kept rounded, which ends comes with in air stream. So whatever air it is strike on this surface, which is rounded, and trailing edges are pointed or the sharp. Now the line connected between leading edge and trailing edge is called chord line. Now the upper surface of the both symmetrical and asymmetrical aerofoil is convex, as shown in this figure. In symmetrical aerofoil, both upper and lower surface are convex type, but in asymmetrical aerofoil, the upper surface is convex type, while the lower surface is concave type.